The theme of this presentation is the system approach in pumping systems. There are three ways to increase the efficiency of the pumping system: the product approach, the extended product approach, and the system approach. The product approach focuses on the efficiency of the pump alone. The extended product approach is focused on the extended product: pump, electric motor, variable speed drive. The system approach focuses on optimizing the pumping system and consider complete system, including pipes, valve, process demand, heat exchangers, filters, and so on. Let's consider the system approach in details. When looking at a system, it's very important to set the boundaries of the system right. This slide shows a simple system where the task is to pump liquid from one tank to another situated at the higher elevation. If the inner box is chosen as the system boundary, we might determine that the system is very efficient as we checked power, flow rate, and head. If the middle box is chosen, the picture probably gets worse. We now see that part of the flow is returned to the first tank through a bypass line. All the flow measured by the flow meter F1 is therefore not being used, and the energy used for pumping liquid back to the tank is wasted. If the largest box is used as the system boundary, we get the true picture of what the system demand is. By measuring the flow at F2, we will know how much of the pumped liquid that is really being delivered to the second tank. The pressure across the throttling valve is also wasted. The true system demand will be determined by looking at the pressure and flow rate that is necessary to achieve the same flow rate with the bypass line closed and the throttle valve removed. Let's consider the real example which demonstrates why you cannot concentrate only on the pump and why it is so important to define the boundaries of the pumping system right. During the assessment, the operation of the double suction pump was examined. The pump circulated the hot water in the district heating system. The discharge pressure was 14 bars. The inlet pressure was 3.2 bars. The pump head corresponding to the pressure was 110 meters. If we look at the curve of the pump, we will find that the head 110 meters lays at the curve very close to the best efficiency point. It looks like the situation when no any additional measures are required. But if we look at the system more carefully and check complete system, we will find some things which will make us think that not everything is perfect. When we walk along the system, we found two control valves. First one was installed in discharge pipeline immediately after the pump, and it was closed on 30%. The second one was installed in a pipeline in another hole, so the overall pressure drop across two wells was about 40%. Let's consider another example which illustrates advantage of a pumping system approach in pumping systems. We have a simple system with throttle control. The discharge pressure is 8 bars. The pressure after the control valve is 4 bars. We measure flow, pressure, and power and calculate efficiency of the pump, 60%. The motor efficiency is 90%. The overall efficiency is 54%. Now we want to increase the efficiency assuming that the delivered head and the flow is what is needed. The system is throttled and half of the pressure is wasted. If we exclude the throttle control, we can use a pump with the same flow but with the pressure 4 bars. We can find a pump with efficiency 71% and motor 94%. In this case, the 7 is much larger, 108 kilowatts. Conclusions. Do not concentrate on the pump or electric motor. Concentrating on elements, you will not get all savings. Look at the complete system and end users. Define the real requirement of the end user. Do not think that present flow and head are given for granted. System approach is the most effective method which gives the maximum effect. Think about what potential improvements for the system can be done. Make your pumping system efficient. If you need more information, please visit our website pumpsaudit.com. See you. Good luck.